Alright, so we are going to solve this system of equations using substitution. And remember, our first job is to pick one of our two equations, and we want to pick one that maybe looks like it's easier to get one variable all by itself. I'm looking here and it looks like equation number 2. I'm going to go ahead and number these. I'll call this 2 and I'll call this 1. And it looks like number 2 to me, it looks like it's going to be easier to get y by itself as opposed to this guy. And the way I kind of know that is there's two variables on one side here. This is going to be easier. So let me show you what I mean. So I'm going to rewrite equation 2 right here. 4y is equal to 8x plus 4. And how do I get y by itself? Well, right now I have this pesky 4 right here, and it's multiplied by y. The opposite of multiplication is division, so I can divide everything by 4. I'll divide both sides by 4. Okay, over here my 4's go away. That's nice. And I just have y is equal to. Now what happens over here? It turns out the 4 is applied to both parts of this numerator. So I need to do 8x over 4 plus 4 over 4. And it turns out we can simplify this even further. I know that 8 over 4 is just 2x, or 8x over 4 is 2x, and 4 over 4 is just 1. So I know now that y is equal to 2x plus 1, and I'm going to use that for my substitution. So it's important to keep in mind the order we use equations. So we just used equation 2, so now I'd like to use equation 1. So I'm going to write equation 1, but instead of writing y, I'm going to leave a nice big gap. So I'm going to write 2, and I'm going to leave a big space, and then minus 4x equals 2. And this is equation 1. I just stole it from up here. And instead of writing y, I'm going to substitute into this equation what I know y to be. So I know that y is just 2x plus 1. So wherever I see a y in my original equation, I can substitute in 2x plus 1 because y is 2x plus 1. That's the core idea of substitution. If you understand that, you're going to go far with solving these problems. Okay, so now I have an equation that only has one variable. It only has x's. There's no y, so that means I can solve it. Once I have one variable, I should be able to solve most equations. Okay, so I see these parentheses here, so I'd like to distribute first. So my 2 gets multiplied by both things. Here I have 2 times 2x. 2 times 2 is just 4, so I'll write 4x. Here I have 2 times 1, so that is equal to 2. And I'll just continue writing the rest of the equation. Alrighty, ooh, something weird's gonna happen. I see, okay. So what happens next, I see I have a 4x take away 4x. That's a little bit suspicious. What happens there? So we know those are like terms. They're like terms because they both have x's. But they're actually kind of opposites. We have 4 take away 4. So what actually happens there is I'm left with 0 x's. So these cancel, which is pretty crazy. So I get 2 is equal to 2. Okay, so this is actually a special case. We tried to solve our equations, we did everything correctly, but our x's kind of disappeared. And what that means, it could mean one of two things. The two options are, it could either be a dependent set of equations, or it could be inconsistent system of equations. If we get a true statement, if we get a statement that's true like this, and as opposed to what I mean, we could have gotten something like 3 equals 5 or something, and that's not true. That would be a different outcome. But if we get a true outcome, then that means that our system is dependent. And there's a graphical representation that I like as well too, but we'll have to save that for another day. If we had gotten a not true relationship, that would have been inconsistent. But the important thing here is this is a dependent system. Oh yes, and final thing, dependent systems have infinite solutions. This sideways 8 means infinity, and it has infinite solutions if it's dependent. There's not just one solution, there are infinite solutions.